Hi, I'm Sinanjit. I'm going to introduce about our project, Process Control System for Sewage Wastewater Treatment Industry. Sewage wastewater is the combination of the water and the waste from domestic and industrial life. The disposal of the untreated sewage wastewater causes water pollution to the lakes, rivers, and oceans, which will cause the marine life is not suitable to survive, loss of marine biodiversity, and affect human health. Therefore, the sewage wastewater treatment industry is required to treat this sewage wastewater and turning them become environmental friendly and harmless to humans. It generally consists of 4 processes to treat the sewage wastewater, which are pre-treatment process, primary process, secondary process, and tertiary treatment process. Besides, the equalization tank installed between the pre-treatment process and the primary process is an important equipment for collecting the sewage wastewater from the pre-treatment process. It helps to increase the efficiency of the treatment and the purity of the outcome water. Moreover, a process control system is also installed in the equalization tank to control the water level of the equalization tank and the flow rate of the sewage wastewater. There are 3 types of controller that normally will be used in the process control system, which are proportional controller, proportional integral controller, and proportional integral derivative controller. That's all for my part. I would like to pass to my teammate to continue the presentation. Thank you.
Hello, my name is Satishwaran Sivakumaran. I'm from Chemical Engineering Group 2. Would like to present about the problem statement of our project. The first problem statement is the untreated sewage wastewater causes environmental impacts. The second problem statement is lack of knowledge in the treatment process involved in the wastewater industry. The third problem statement was unaware of requirement process control needs to be installed in a wastewater treatment plant. Of our project is to study the treatment processes and the process control system in the sewage wastewater treatment industry. Second objective is to design an effective waste control system for having a clean production process which was zero waste is produced. The third objective is to study the 3 types of controllers which was P controller, PI controller and PID controller and choose the suitable controller that is used in the process control system.
Hi, my name is Chen Sang-Yuan. Next, I'll be talking about the processes involved in the sewage wastewater treatment process. Primary treatment process helps to remove the solid and oil from the wastewater and stabilizing the condition of wastewater. Secondary treatment helps to remove the biological waste, chemical contaminants, and soluble gas in the process. Water has reached the minimum of standard B of water effluent by the EPA, thus already achieving zero waste strategy. Tertiary treatment process of wastewater will remove the pathogen from wastewater for commercial use. Process control system of our group will be the level control of equalization tank. The wastewater inlet of the sewage wastewater is always in an uncontrolled condition in which the flow rate, pH, composition are always fluctuating. The presence of equalization tank will accumulate the inlet flow and cause a quasi steady state of mixture. The mixture will then be transferred to the secondary treatment process with a steady outlet flow. The working mechanism of the equalization tank is as follows. The set point will be set as the level of equalization tank, while the process variable will be set as the opening percentage of equalization tank outlets. When the water level reaches the maximum level, the controller will increase the outlet flow rate to prevent overflow to prevent the cost of overflow for cleaning and maintenance. When the water level reaches the minimum water level, the control action will decrease the outlet flow rate to prevent drop and the wearing of engine inside the pump. When the control action will stop when the water level reaches the optimal output or input ratio, which is the most cost effective. For controller, PI controller is used because the gain helps to increase the step change, which leads to faster control action. Integral time constant will help to remove the offset of the process. Derivative time constant is not considered because it will complicate the tuning process. Besides, speed is not very important factor in this process and the abnormal level does not occur frequently. Thus, it is not necessary to have the derivative control in this process.
Moving on to the next part, which is the challenges faced by equalization tank. First, the challenges is aeration or mixing system. First, by having insufficient mixing rate, the sewage effluents consists of domestic wastes, which mainly consists of solid particles, can cause sedimentation, and ended up, the solid particles consume a portion of capacity held by equalization tank. This could affect the efficiency of next following operation units and can cause overflow of sewage effluents. Next is the inlet flow rate fluctuate. So as we know, the inlet stream of equalization tank coming from the various sources of wastewater. So the water comes into the equalization tank at varied flow rates. So this unknown flow rate will cause a few implications toward controlling system. One of them is the overflow of sewage effluents inside equalization tank. Moving on to the last challenges of our project, which is the accumulation of sludge. The sludge carried by sewage effluents into the equalization tank. So this mixture is contained inside the tank. So when there is no mixing process, the sedimentation of solid particles occurs and eventually forming a sedimentation layer inside the tank. So this will consume a large portion of capacity for volume and requires cost to treat the sludge accumulated inside the equalization tank. Moving on to the modification recommended by our team. So first one, by having aeration system. Next, by installing transmitter for both flow rates and liquid level. Last but not least, by having software to simulate the operational workflow for our equalization tank.
For the last part of this presentation, I will be the one to conclude the whole report. As explained previously, the project focused on a process control system to produce a zero waste industry. Hence, our group has decided to use a PI controller in the sewage wastewater treatment industry. Hence, let me conclude the main points of this report. The findings in this report comprises of 3 parts, which are: first, the process control system and its justification; second, challenges in process control system; and third, recommendations for the equalization tank. For the first part of the experiment, the PI controller was chosen based on its findings and suitability of the controller in the equalization tank. And for the second and third part, the challenges discussed in the second part can be reduced and improved by the recommendations discussed in the last part. So in conclusion, such zero waste from sewage wastewater treatment industry can be implemented so it can contribute to one of the environmental friendly industries. Thank you.